Hello friends, welcome back to JEE Blunders, where you learn the don'ts first. So today I thought we could start off with a very innocent looking problem that will hopefully teach us a very important lesson in the same series, Trigonometric Equations. So let's get started. We want to solve the equation tan x equals secant x. So using the definition of tan and secant, we can rewrite this as follows. Sin x by cos x equals 1 over cos x. And so cos x cancels. And so we have sin x equals 1. And so when does sin x equal 1? So drawing our unit circle for reference, sin x equals 1 whenever the angle is right here, right? So the general solution for this equation is that x must be an even multiple of pi. So it must be somewhere here, and then you add a pi by 2 to that. 2n pi, so an even multiple of pi, so that you're somewhere here on the circle, and then you add a pi by 2. Right? So that is the most general solution of x. And by substituting different values of n, let's start with n equals minus 1. So x equals minus 2 pi plus pi by 2. So that's minus 3 pi by 2 for n equals minus 1. N equals 0, x would be pi by 2. And n equals 1, x would be 5 pi by 2. So yeah, we are done, right? But if any of you have identified that something is wrong, please pause the video here and think about what actually happened. So assuming you have paused the video and you're back, let's just try substituting some of the solutions back in the original equation. So tan, let's try this one, right? So tan pi by 2, does tan pi by 2 equal secant pi by 2? Well, the answer is we don't know, because this is not even in the domain of the function tan x or in the domain of secant x. So what exactly happened here? This is a very interesting problem, right? So let's rewind a little bit and understand what exactly we did. So we started off with the equation that was given to us, and then we rewrote that as sin x by cos x, and we rewrote tan x as sin x by cos x, and rewrote secant x as 1 by cos x, and that is fine. Now when we cancel cos x on both sides, what we actually did is we multiplied both sides of the equation by cos x, and then we cancel that out. So that is what we actually, that is the meaning of cancellation, right? You multiply both sides of the equation by the same constant or the same expression. Now when you do that, it is important that both sides are not, you cannot, if you multiply both sides of an equation by 0, then it will always satisfy. So you start off with a equals b, and you multiply both sides with 0, you get 0 equals 0. So that will always be true. So that doesn't give you any new information, right? So that is what we have done actually, because we multiplied both sides by cos x, then we tried solving it, and all of the solutions we got are the values of x where cos x equals 0. So essentially what we have done to solve this is to multiply both sides by 0, and then we got 0 equals 0. And so that means none of the solutions that we got here are actually correct, right? So so this seemed like a very simple problem, and it was just one step literally. But the important lesson that we learned is that you have to be really careful when multiplying or dividing both sides, or let me rewrite that. Oops. Or dividing a trigonometric equation. because you could multiply both sides by cos x or sin x, but for some values of x those are going to be 0. So you just want to make sure you're not multiplying both sides of an equation by 0. So that is the important lesson learned from this very innocent looking problem. But before I finish, let's try to actually solve the problem that we started with, right? We wanted to solve for, the values of x where tan x equals secant x. Let me just scroll up. So the safest way to do this, in my opinion, is to follow a graphical approach. Okay, so tan x, let's try graphing tan x first, which I will do in a new color just for a change. Let's do pink. So let me scroll down a little bit. Okay. Yeah. So tan x doesn't have pi by 2 or odd multiples of pi by 2 in its domain. So you start off somewhere here, right? And it is a periodic function. Sorry about that. So you have something like this, right? This is how tan x looks. So the pink line is tan x, just to have a legend here. And then let's quickly graph secant x in a different color. Now secant x is 0, or secant x is 1, excuse me, when x equals 0, and it will be 1 here, right? And secant x will equal -1 when x equals pi. Yes, and secant x is also periodic function. Okay, now so this is the graph of tan x and this is the graph of secant x, and now we want to solve the equation tan x equals, the pointer has been giving me problems for a while, tan x equals secant x. And so my question for you is, where do these curves intersect in this graph? So if they intersect anywhere, those would be the solutions of this equation, and if they don't intersect anywhere, that means this equation doesn't have any solutions. With that, hopefully you found this interesting, and I will see you in the next video. Bye.